Okay, so you have your calculators? Got your calculators? What's the first thing you should check for in your calculator? If it's on degree mode. So I would check your calculator. There should be 2 at each table. Make sure you are in degree mode so you don't start getting a whole bunch of wrong answers. Okay, so Jason leans a 12-foot ladder against the wall. The base of the ladder makes a 60-degree angle with the ground. What is the distance from the base of the ladder to the base of the wall? So you're going to notice this is a B level. The ones where they already give you the triangle and you just have to find a part of it, those are C level. If you have to draw the triangle from a story or words and then solve the problem, that automatically bumps you to the B level. Okay? And then when you have to do multiple things like perimeter, that's going to get you to the A level. Okay? Just so you know when you take your test on this. Okay, so we need to draw a picture of this. I'm going to draw a picture to the right so I have some space, and then I'll do the work underneath it. Okie dokie. So we have a ladder leaning on a wall. Which way does a wall have to be going? Up and down. Don't be weird and make your wall like this. We know what a wall looks like. What is automatically in a picture, even though they don't talk about it? The ground, which is going to be a horizontal line. So in your picture, you do need the ground. I will make it green because it's grassy, I guess. I don't know. I'm going to make a wall. I will make my wall gray, like it's a cinder block. How that's my wall. And now I have a ladder leaning on it. So where does that mean the ladder has to go? It has to touch the grass. It's leaning, so it can't be straight up and down. It's got to lean up against the wall. So it's going to be looking like this. Well, I don't really know when I start drawing the picture, so I just made my grounds. But yeah, you can cut those off. This is my ladder. I'm just going to put a little note by here. This is my wall. And this is the ground. Just so I have an idea what my picture looks like. Because remember, if you start with a picture that's jacked up, you're clearly not going to get the right answer. So these have to be right angles. Is there automatically a right angle in this picture? Yes, the wall and the ground do meet at a 90-degree angle. So I do have my right angle right here, correct? Okay, that is my picture. Okay, so let's see if we have that other information about it. So let's go back to our reading. It says Jason leans a 12-foot ladder. So what does that mean is 12 in this picture? My pink, my gray, or my green piece? Pink. That is my ladder. So my ladder is 12. I'm using different colors just so I can see what's going on in my picture. The base of the ladder. Okay, so in this picture, where's the base of my ladder? It's on the ground where? Here or here? This is the base of my ladder, the bottom of my ladder. We've seen a ladder sitting on the ground. So I'm talking about this point here. So the base of the ladder, the bottom of the ladder, and the ground, so the bottom of my ladder and the ground, make a 50-degree angle. So that means that this angle down here is going to be 50 degrees. Now, I know that's 50, and I know this is 90, so I could get that angle up there if I needed it, right? I mean, I don't right this minute, but I do know I can get it because the total inside is 180. So it is usable if I need it, right? Okay, so what else do we say here? What is the distance? The distance from the base of the ladder to the base of the wall. So I need to go from the bottom of the ladder to the bottom of the wall. Now, what color is that piece in my picture? The base of the ladder to the base of the wall. He's green in my picture. You see him? Okay, so I'm going to be finding this green piece from here to here. So that's the piece I want. the ground piece that's in between the ladder and the wall. So that means I need to name him a variable. What would you like to call him? Q. We're going to make him Q. So we're going to call this Q. All right. Okay, so now we have our picture. So that takes us out of the C level and up to the B level by drawing this picture right. Now I got to do the rest of it. So just like we did all the other problems, what's the first thing I'm going to do? Yeah, I got to circle the angle and label my part. So go ahead, circle your angle. Which angle are you circling? The 50. So it's this yellow guy right here. Circle your angle, label your opposite, hypotenuse, and adjacent from there. Okay, so who is my hypotenuse? The 12. So this is my hypotenuse. Who's my opposite? The wall. So this is my opposite. And then my bottom is my adjacent, right? Okay, so remember we circle our angle, label our stuff. Now we need to decide who gives us nothing, who's out of the game here. Who are we not using? Because we only need 2. So what do you want to keep and what do you want to get rid of? Get rid of opposite. So does everyone see you're going to get rid of opposite? Because we have hypotenuse and we got this Q, right? Which is basically what we're going to find. Opposite, we don't have anything and we don't want anything right now, right? So he's out of the game. Gone. Okay, so that means we say what we're using, where we are using a hypotenuse and adjacent. Hypotenuse and adjacent. Sorry about that. Okay, hypotenuse and adjacent. And so look at your thing, SOHCAHTOA. What do we want to use for hypotenuse and adjacent? Cosine. So let's put down cosine. Remember, all of these are the same 5 or 6 steps. We always pick our angle. We always label our sides. We always decide which 2 we're going to use. Then we pick our trig ratio we're using, which is going to be cosine. And then we always write our next equation the same z. We always write it. Our trig ratio, then our degrees, your angle, equals your fraction, right? Okay, so how are we going to write this guy? What do we have to write first? Cosine first, right? And then what? Always our angle. What's our angle? 50. Remember, sometimes we know it, sometimes we don't. If we didn't know it, there might be a variable like x or theta or y or something, right? And then always equals. And then always our fraction. So you guys said to use cosine. So what's our fraction going to be? Adjacent over hypotenuse, which you say is q over 12. And then we're going to use algebra, right? Are we using the second button for this problem? When do we use second button? When we're looking for an angle. We're not looking for an angle because we have the angle already, right? We have 50, so we don't need to hit the second button. So we do just have to do some algebra. What is our, put that in your calculator. Remember, during your work, go out to 4 digits. So pick up your calculator, because I don't think anyone knows cosine of 50 degrees in their head right now. Nobody does in the world. Okay, give me 4 digits out. What do we got? Cool with that? Okay, equals Q over 12. I don't know. I wrote down what someone said. Now remember, if you're going 4 digits out, you can round or cut off. It doesn't really matter because that's why we go 4 digits. That way we got that extra leeway. So we can round at the very end or you could round now. So if you put that as an 8 or a 7 right now, when you get to the final answer and round to the tenths or hundredths place, everyone will have the same answer. So it won't matter. So you can if you want. Now what? Do your algebra. Over 1, crisscross, solve. And when we're solving and getting our final answer, you can go ahead and round to the tenths or hundredths, whatever looks pretty to you. Because it does not tell us in this problem what to do. But we don't need 4 digits anymore. So we got Q, because we got 1 Q on one side, which is just Q. What do you have when you multiplied by 12? 7.7. Are you guys happy with that? I do not have my calculator, so I'm taking your word for it. 7.7? Yeah, good. Okay, so what was this? What were we answering anyways? It says, what was the distance from the base of the ladder to the base of the wall? So that is 7.7. And this is a story problem, so give me a story answer. 7.7 what? So it is, this down here is 7.7 feet. Delay. 7.7 feet. Which seems okay, right? You have your wall, you have your ladder 7 feet away going up. Sounds like it makes sense, right? And there is a part 2. Okay, so part 2 says, how high up the wall does the ladder go? So you don't have to redraw the picture unless your picture is too much of a hot mess that you can't piece it together. So I'm just going to, just for the sake of our notes, I'm going to draw a baby one right underneath here without all this junk on here. So here's the stuff we know. We know that's the right angle. We actually know this down here is 7.7 now, right? We know this is 12. And we know this is 50. So those are the parts we know, right? Yeah? Okay. Like I said, you could use the same picture, but I have a lot of stuff going on. So same thing. All these parts are the same, right? So that is still my angle, right? This is my opposite, right? This is my hypotenuse. And this was my adjacent. I just redrew it with my new information and less junk. Okay, so the question says, how high up the wall? How high up the wall does the ladder go? So are we talking about the ladder or the wall? How high up the wall does the ladder go? So this was the ladder, and this was the wall. What are we looking for? The wall or the ladder? We already know the ladder. The wall. So we need the wall. So we are looking for from here to here. Because if I say how high up the wall, this was my wall. Right here is how high up the ladder reaches. Way up there on my wall, right? So this is the piece I'm looking for, my pink piece. What variable would you like to call him? Y. Okay, so we're going to call this Y. So we're going to be solving for Y. So which pieces do I need to use for this one, and who do I want to throw away? Okay, I have to use this. So, and I have to use one more. Now I have the 12, and I have this 7.7. Now which of these is a better number to use? 12 is better. Why is 12 better than 7.7? It's actually because we rounded the 7.7, right? So the 12 is actually more precise. So he is the, ooh, P is the better one to use. So I would use this one. Now you could use the 7.7. You're still going to get a perfectly good estimate. So it's not the end of the world. But if I have one that's perfect and one that is rounded, I'm going to pick the perfect one instead. Although you could pick both, either. Okay, so I'm going to be using opposite and hypotenuse. So write down opposite and hypotenuse. My options are sine, cosine, tangent. Which one am I going to use? Sine. I'm going to be using sine right here. Sine is opposite over hypotenuse. So sine is the winner, winner, chicken dinner. Sine. My board is frozen. I can't draw. Okay, so you're using sine? Yeah? I was trying to draw a star here. But it's not responding. Okay, so what are we going to write underneath there? Sine 50. You just have to listen to me because I can't write. So sine 50. Then what? Equals the fraction, which is opposite over hypotenuse, which is y over 12. Okay, I'm back. So sine 50 equals y over 12. And you're going to finish this problem. So exactly like you just did up here, push all your buttons, crisscross multiply, get your answer, and finish your problem. I'll give you a minute. And remember, this will be glued on page 50.